All right, so let's move into the next section, and we're going to be looking at equations, and we're going to be looking at lines or linear functions, and looking at some of the terminology that you need to know about lines and those types of functions. So we have a couple of vocabulary terms that we're going to learn, which are rate of change and slope. And what you're going to see is that both of them are pretty much the same thing, and actually, I probably would even venture to say that they are both exactly the same. So just different ways of identifying them, but rate of change would be something like miles per hour, like a speed, anything like that. Miles per gallon, that's a rate of change. Anything like that that we're kind of seeing, that's what it is that we're dealing with. And then, of course, slope is if we have a line, we're looking at how fast it's going up or how fast it's going down. If it's doing either, it could be a horizontal line. So we have a lot of different things that we're taking a look at. So looking at terminology first, we're going to see this rate of change. And so the very first thing that we do is try to figure out what is the equation for the rate of change. And so for the rate of change, we have this equation, which is delta y over delta x. Now, that's big terms for freshmen, and for Algebra 1, we're not really going to use those terms, but the book does use these terms, which is change in y, or change of y, over change of x. And so those mean the same thing. So we have delta y, delta x, and then when we look at the actual equation, it's y2 minus y1 over x2 minus x1. And I should have written these correctly. That looks like a squared. That looks like to the first power. That's not the way it's supposed to be. So we have y2 minus y1 over x2 minus x1. Now, what does that mean? That means if we have 2 points, so let's say we have a point here and we have a point way over here, this would be my first point. Doesn't have to be, but this would be my second point, for example. Then we would have x1, y1 here, and we would have x2, y2 over here. So that's how we identify them. So notice we have 4 values total. We have 2 values with the first point, x1 and y1, 2 values for the second point, x2 and y2, and then we would just plug them into that equation. This equation right here, we'd plug them in and figure out what the rate of change is. Again, as I mentioned kind of subtly at the beginning, it doesn't matter which one we call point 1, which one we call point 2. It really doesn't matter. So the negatives and positives will work each other out, and it will state exactly what's going on. If you notice in this particular example, if I draw a line between these two, and I've mentioned this before with an equation, is in this particular case, we have a positive slope because the line is going up, and we always look from left to right. And what's also going to be really important is we always want to start with the leftmost point when we're trying to decide if it's positive or negative. And then if we have a negative slope, we might have 2 points that are over here. You can see obviously that the line is going down as we move left to right, or as we start with the leftmost point, which is this one right here. This one is the rightmost point. And so this slope of this one would be negative. Okay, so that's what we're kind of looking at. Now we do have other lines, and we have talked about these other lines before. And so if I have a horizontal line, let's say that I have a point here and a point here. Horizontal means it goes along the x-axis. That slope would be 0. If I have a different line, pick a different color. So let's say that we have those two. If I have a vertical line, so I have this point up here and this point down here, then we have a vertical line. That line right there, its slope is undefined or infinite. It's in normal math terms, we say that the slope is actually infinity, but sometimes books will say that that's undefined. They actually don't mean the same thing, but we're not going to really worry about these for now, so I'm not going to confuse you with all that information. The important thing is know what a positive slope is, what a negative slope is, and what a zero slope is. So we'll see all those. So of course, positive is black, negative is blue, and 0 is this orange. I think that's an orange color. Maybe it's a red color. Remember, I'm colorblind. So The slope, what's the equation of a slope? Well, y2 minus y1 over x2 minus x1. And I won't go into any more detail because it's the exact same equation. Okay, so we're going to calculate one slope here, or actually in this problem we have a rate of change. So notice that we have a problem here, and it says, and this is learning the rate of change, by the way. Remember to always go through the presentation charts because it'll give you some information. If we look at it, notice it's change in y over change in x, and it's of course the change between two values in the y variable, and then change in x over the two x values. And it's a little bit more technical than what I wanted to go into, but just wanted to kind of show you. So now we're going to find the rate of change. So notice that we have, hold on. So notice that we have some values here. So we are given this table. We see that the time in hours versus the amount earned. So if I work 8 hours, I earn $62. If I work 12 hours, I earn $93. So I have this here. X is, of course, the first column. Y is the second column. That's very typical in any kind of table that you're going to be given, especially for Algebra 1. They might try to confuse you in Algebra 2 and switch them, but it doesn't matter. Remember that in a point, whenever we're dealing with a point, X always comes first, Y always comes second, no matter what. So what I'm going to do now is I'm going to label something. So I'm going to say this is my first point and this is my second point. Now I'm only doing that so I can see how it lines up. Remember, it is y2 minus y1. So 93 is my y2, 62 is my y1, and then x2 minus x1, 12 is my x2, and 8 is my x1. Again, if I reverse those, I would just have to be consistent, which means I could have written it as 62 minus 93 over 8 minus 12. Notice these go together as an x and y pair. These go together as an x and y pair. Okay, and that's critical. So don't just do it because you're going to have positives, because that will throw all your numbers off. So you want to be really careful with that. Okay, 93 minus 62 is 31. 12 minus 8 is 4. We check to see if we can reduce that down. We cannot. Therefore, that is my answer. So 31 over 4 would be my answer. Notice that that's what we have. So it should be 93 minus 62, 12 minus 8. And those would be my answers that I would put in there. Okay. Comparing rates of change. So when we're comparing rates of change, we're going to look at two different rates of change, which means we're going to do different numbers at different points. And we're going to see, for example, find the rate of change between 10 and noon. So notice here is 10 o'clock, here is noon. So we're going to go up. So when X is 10, Y is 60. When X is 12, Y is 65. That's going to be one of them. Then we're going to find the rate of change between 2 and 4. 2 is actually 1400. Be careful. This is 2 a.m. This is 2 p.m. So at 2 p.m., we have 68 degrees, and at 4 p.m. we also have 68 degrees. So we're going to use those numbers to compare them. Okay. Now, usually they ask you a question. So what does it mean in the context of the situation? Well, just looking at the graph, you can kind of see it, but we're going to show it. You can see that between 10 and 12, the temperature goes up. And then between 2 and 4, the temperature stays the same. So that means that the rate of change between 10 and 12 is going to be greater than the rate of change between 2 and 4. Just by looking at the graph, I can see that. But let's do it with numbers. So we're going to compare those. So notice that 10 and 60 degrees go together. 12 and 65 go together. So it doesn't matter which one. We're going to pick this one as 0.1. This one is 0.2. So we have 65 minus 60 because the y values go in the numerator. The x values go in the denominator. We're going to line them up just like we did up here over in these. Notice the 12 and the 65 and the 12, because this is y and this is x. We get 5 over 2, so that's our answer. On this side, we're going to do the same thing. This time I'm going to pick this as 0.2 and this one is 0.1. Again, it doesn't matter. So we have the second point first. So it's 68 minus 68. You can't tell the difference between those because they're the same number. But we have 2 minus 4. right? Because we do the second x. And so that would be 0 over -2. That's still 0. Anything 0 divided by any number other than 0 is always going to be 0. Okay, little subtle difference there. So you notice that the slope of the first part between 2 and, between 10 and 12, that the temperature goes up. You can see that. And then between 2 and 4, the temperature stays the same. And that's going to be the end of the first video. We'll go to the next one to keep calculating rates of change and then getting into the slope.